Good morning, or good afternoon, or good evening to everybody, and thank you very much for joining today's webinar. My name is Richard Smith, and I'm Global Applications Manager at Taylor Hobson. During this webinar, we'll take a look at some examples of multi-part measurements on Taylor Hobson's Talyrond and Form Talysurf systems. We're going to have a look at the rotary stage or the carousel on Talyrond systems, and then a look at the production interface using palette mode in Metrology 4.0 software. And then finally, we'll have a look at how we can measure multiple parts or features using just a single program in Metrology 4 software. So we'll start with the rotary stage, also called the carousel, and this is available on the Talyrond 500 HS system. It is in the picture there and on the right, and you can see it is loaded with some components. It provides ultra high precision multi-part measurement, and this carousel can be taken on or off, so it can be used with the carousel or without the carousel. So the user simply loads these components onto the carousel fixture, and in this example here there are 20 parts fitted. What happens is that the carousel rotates to bring the selected part over the instrument spindle axis. And if you look on the right, you can see one of the parts is over the center of the spindle axis, and that's the one that's going to be measured. So first of all, what happens is the system aligns that part, it centers and levels it, and then it measures it for roundness, surface finish, contour, and all the measurements that we require. It's also possible to fix a calibration ball as one of these items in order to calibrate the gauge as part of that and stylus as part of that process. On completion, the carousel moves to the next angular position and the process starts again. So let's have a look now at a short video clip of this. The carousel is loaded very easily. It's plugged in, and the samples can easily be removed there between those pins or inserted in place. They don't have to be the same samples, they could be different ones, provided the program allows for copes for that. So we're measuring the first sample there and then moving off, and you can see we're going to move to a different location. We've indexed round to the next part. One thing to note here is that the weight of this is offset, but it is counterbalanced. There is a counterbalance inside here to make sure that the weight is balanced evenly about the spindle axis. So when we're measuring on the carousel, there is no loss of accuracy, and we'll have a look at some of those results in a minute. So maintaining accuracy even though we've got multiple parts. I'm going to move again now to a different position. And we can choose whichever part we want to measure. And now it's easy once we finish to remove the carousel, just unplug it and take it away, and we can use the Talyrond 500 HS in its standard mode. So what sort of results do we get? Well, for those 20 samples that we've just seen, what we did was we took the 20 samples and we measured them 20 times, 20 runs here down the left, and across the top the results for each of the 20 samples. And in this case, we were just looking at the roundness in nanometers. So for example, for sample 1, these are the results on each of the individual runs, and the standard deviation was only 5.3 nanometers. With a a spread, a deviation of max to min of only 21.7 nanometers there. And so typically we will get below a spread of about 30 nanometers. And in this case, we've got a extremely low standard deviation of less than 10 nanometers for these results. And that really compares perfectly well with just measuring a single part. And that's the key to this device. We don't lose accuracy when we do measurements. Not only can we measure the parts you saw, but we can also measure roller bearings, ball bearings, injectors, medical components, hip joints, and teeth. I can't think what they're called. Teeth. Yeah, teeth implants. That's the word I want. So next, we're going to look at the production interface. Here is the production interface in Metrology 4.0, and this is what it looks like. On the left, we can see the PGI Novus with Metrology 4.0 software, and the production interface as part of that comes as standard as part of that. And we're running it in what's called palette mode, and that means that we can arrange for it to deal with a set of parts. So we've got a set of parts on the left there, multiple parts, and each of these is indicated site 1, site 2, site 3, all the way, in this case, just showing 5 sites. We can select or deselect these sites, so we can choose which ones to measure. We can put different parts in different positions if we want. And there is a reference, the choice of using a reference ball, which we'll see in a minute in the video. In the interface, we can decide which parameters we're going to measure. In this case, it's RZ, RA, WT, and distance. There's no actual results because we haven't measured yet, but the nominal results are shown here. The nominal values are shown here with the upper and lower tolerances. And let's have a look now at the video doing just that. So here are the results that we would get out, and we'll run the video all the way through. So there's 5 parts there and a reference ball for starting. So you can see on the bottom right here, we're now finding the position on these parts that we want to measure relative to this reference ball. And you can see that it's flashing there telling us what we're measuring. So we're measuring the first part, and in the bottom right you can see it's indicating live what we're doing. We're measuring the first part, and once it's measured, as soon as it's measured, you'll see those results come up in the bottom right there. The results on the bottom right have passed, and you can see that's indicated there. We're now measuring the second component, and the part indication down there has gone green to indicate that that's passed. So the second one fails, and you can see how much out of tolerance the results are, and so on. So now we're measuring the third part. That's passed. The fourth part has failed, and finally the fifth part has passed. So we've only shown 5 parts there, but we could have many, many more parts if we required it. The results can be viewed there individually, as you can see, or they can be viewed side by side. They can also be put into this table that you can see here, where the pass and fail conditions are indicated. You can call up old measurement reports. This one that they've all passed, and this is an example of the report on the right here, and you can see that the folders are time and date stamped, and in the report it contains a full report, individual results, and all the documents and data in these date stamped folders. So a very powerful way of taking parts, measuring them, indicating what's passed and failed, and at the end of it all, getting a report. Let's have a look now at how in Metrology 4.0 we can measure multiple parts, but just using a single measurement program. And this is done using the ability in Metrology 4.0 to use variables. So when we start the measurement, we can scan with a barcode or a QR code scanner, and that will tell us which part that we want to measure, and it will call up the data about the information about the part that we're measuring from the database, from the company database, or even from a text file locally on the PC. So that's one way of starting the automatic measurement process. Another way is to do it in a user-defined way, where the user says which part is to be measured, and you can see that in the picture at the bottom left here. In this case, we've typed in part B, and so it will go and measure on this demonstration sample here, part B in the middle. The third way, which we're going to look at in a minute in a short video, is the ability of the software to detect what part is there. So if we've got a short part, a medium-sized part, or a big part, we can take a sample measurement of the surface. And in this case, we're looking at this length here, which is this length here. And we're saying, depending on how long that is, I know then which part it is. And then I can call up all the data about each of these, the relevant component, before I do the measurement. The way it works then, the whole process that we've just been talking about, we start the program and we determine the part type, either by a barcode or by sampling the surface, or by telling the system which part we're measuring. And in each case, it will read the variables about that part from a database or from a file held locally on the network. Note that the information about the part doesn't just include the length or dimensions of the part, but it also includes other things to do with the analysis. So we could choose how we want to analyze that part. In this case, we're using a short LS filter, a short wavelength filter of 0.8 millimeters. But for part B here, we're using a filter of 0.25 millimeters. So all of that can be kept in the company database and called up just by the barcode or the other methods before we start the measurement. So let's have a look at the way we can automatically detect which parts are there. So in this video, we're going to see multi-part measurement using a single program. We're going to see how the variable inputs are read in from a text file. And then we're going to have a look at some of the analysis. So on the right here, we've got the three parts, different sizes, A, B, C, and we'll progress now through the video. So there are the three parts. And the first thing that happens is that the start of the program, there's no variables there at all. And the stylus now references, in this case, off the edge of the fixture in the top left, you can see it. And it takes a measurement of the part. It's going to move down now to position A, and it's going to measure that short measurement, and it's identified that it's part A, that it's a small part. And so part A has been identified, and it reads in the length of 39 millimeters there for the small part, and it fits that back into the table. This is all happening in the background, and this is just to illustrate how this is working. Now it's going to do the same thing on the middle part and say, what is this part? And this time it's identified that it's a medium-sized part. And it's identified the medium-sized part. It then goes and looks up in the database or in the text file there, and it says this medium-sized part is 55 millimeters long. And finally, for the longer part, it's identified that it's the big part, part C. And now it goes and reads from the text file, it reads that that is 70 millimeters long. So once it's got all the information about a part or the parts that are being measured, it then can then go and measure all of those using one program. So all the details of the parts in our palette or in our fixture are known. So it's now measuring the middle part over the full length. And then finally the bigger part over 70 millimeters. Once all the results are in, they can be automatically analysed, and you can see in the table there that we've looked at the pitch between two Gothic arch surfaces in each case. We fitted a ball to these Gothic arch surfaces, and we're looking at the distance between the centres of the balls. Take that a step further and also measure, for example, the roughness, the radius, or the angle, and so on. So a very powerful way of using variable programming, which enables users to automate measurements of a multitude of part sizes without the need for a multitude of programs. So in summary, we've looked at the rotary stage or the carousel on Talyrond systems. We've looked at the production interface in Metrology 4.0 software. And finally, we had a look just now at a single program that can be used to measure multiple parts or features. For the rotary stage and for the measurement of multiple parts using a single program, there are application notes for each of those, A151 and A158. Please visit www.taylor-hobson.com for more information about our products, and also to be able to view previous webinars as well. So on the website, you'll also be able to see a bearings applications brochure, and also find details of other webinars. So there will be webinars coming up, and please do take a look also at our recorded webinars. I'm going to pause at that point and say thank you again. I don't think there are any questions that have come through, but once again, thank you and goodbye.